Hi everyone. What I want to do is I want to install the software for the GPS dongle uBlock 7. I'm going to install this on a Raspberry Pi 3B Plus. First thing you want to do is don't plug in the dongle yet. Okay, I have my Raspberry Pi over here and I have some commands and some preferences for some files that I need to type in. So this will be available in the description below. All right, let's install our packages first. So you can always click on the terminal and it gives you this window. Let me talk a little bit about what this is, this line that we're going to type out or paste. Sudo is the super user, which allows me privileges to install and to do things in the system. apt-get is built into the OS so that I can install packages. It has a -y to say yes to yes or no questions. So these first three packages will allow the Pi to recognize the dongle. Not only that, it provides a toolkit based on the National Marine Electronics Association specifications, NMEA. That acronym is going to be seen. That's going to be something that will identify the dongle for us. You'll see that later. And it will install some apps for us, like xgps and cgps. Okay, then we have Chrony, which is another package that will allow the system, the Raspberry Pi computer, to grab the time from the dongle. And then python-gi-cairo, that program or package is used for xgps. Okay, note that there are many YouTube videos and articles on installing the uBlock 7, and I've seen 6 or 8 videos, read many blogs, and most of them are very similar, but sometimes there's a few tweaks. And those are the few tweaks that you need to take into consideration, especially if you're trying to figure out how to do this. So python-gi-cairo is sometimes not seen in the installation process, but I do need it for xgps. Okay, so let's enter. While that's installing, the reason why I need a GPS dongle is for the time. When I take the Raspberry Pi and the radio out in the field, I don't have the proper time. With the GPS dongle, it's going to provide that for me. When you work with different digital mode communications like WSJT or FT8 or JS8, you need the correct time to communicate from one station to another. Okay, now let's do the next step. Let's copy this command so that we can tweak. In this case, it looks like it's a daemon, but sudo, again, allows me privileges to do things. In this case, I'm going to use an editor, text editor called Pico. You can use VI, Nano. And then you got /etc, which is a folder, /default is another folder, and GPSD is the daemon. Now inside this program, this daemon, this thing, there are, you need to configure it. Okay, so how do I configure it? I have a few things here that I need. For example, start the daemon. Yes, true. Okay, that's good. USB auto. Is it true? Yes, we do want that to be true. Devices. Okay, your device should be called /dv/ttyacm0, and that's not an O. Okay, and it's within the quotes. And then GPSD options, -N. Okay, make sure that's correct. And then the next thing you want to do is type this out. Now, this is one of those things that sometimes you don't see in the videos. And in my situation, this is something that I need to install. And you might not need it for your implementation. But again, keep in mind, these installations, they're always tweaked. And this is one of them that I had to add. All right, so I'm going to press Control X. Do I want to save? I type Y for yes, and then enter, and it saves it. So if I press on the up arrow key, it types the same thing. And if I press enter, I can see if it's saved. Yes, it did. Okay. Then Control X to get out. You don't have to do that, but I like doing that just to see if everything was saved right. Now, here's the next command. This time it's a file, configuration file. I type, again, sudo pico etc chrony.conf for configuration. Press enter, and this one has a lot more. Okay, so what am I going to do? I'm going to comment out. So what I'm going to do is I'm going to type in a £, and you can see the color changed when I did that. See that? It's in white, means it's active. Put a £, it's not going to activate. Okay, there's a lot of things that are, kind of weird, confusing. And, you try to learn the best you can, especially when you're working with one of the Unix flavors, like Raspbian. Now, here's the next thing that we're going to copy, and I'm going to paste. Not everybody also puts this code, but I am, because this is going to help chrony to figure out what device should I be listening to. And here's that NMEA. All right, so we're going to save this, Control X, and I'm going to type Y, and I'm going to press enter. And of course you can go up and return, see if those have been saved. You don't have to do that. And then Command X, yes, it looks good. Okay. We are now ready to restart. This can go way faster, absolutely, but taking your time to make sure it's typed right is crucial. So what I'm going to do is I'm going to restart the machine by typing reboot to restart, and I'm going to press enter and do a little movie magic. So while it's rebooting, go ahead and take the dongle, put it on the Raspberry Pi. Okay, so the machine has restarted. And let's see if the GPS daemon and the chrony daemon started. We're going to copy this command here and enter. It says active, so the GPS daemon seems to be working. Chrony D, the daemon. Is that working? Yes, very good. That's a good start. Now what we're going to do is we're going to go to chrony C sources V. Now this will tell us who's in charge of the time, or what application or what hardware is looking at the time. So you can see that here you have a £, which is the local clock. What is it doing? Well, there's a question mark. it's unreachable. What's unreachable? This right here, which is our dongle. So we're definitely going to have to wait until the GPS is synced with the satellites. Now, don't forget to plug in your GPS dongle to the Raspberry Pi. When you plug it in, you will not see it blink. You won't see a green light. And when I first did it, I was like, oh no, it doesn't work. It's broken. It's not. It's going to take some time. Now, we're going to go to this program here, cgps-s. I'm going to copy that. I'm going to paste it here. And this will start populating when it starts to look at the satellites. And then we can also do xgps. So let's copy this. Let's open another window. Let's paste xgps. And we'll move this here. And right now, no time has come into the system. And you don't see any of the satellites as well. Okay, we're going to make this a little bit smaller. This will take some time. Now, one thing we can also do is type this sudo chrony tracking. Let's open another window. And let's paste that and run it. You can see over here it says leap status not synchronized. So there are no satellite signals. There's no data that I see that is coming in to the dongle, and right here it's not synchronized. And you can also, where's the, let's also open that other window, right? The sources. And we know we have a question mark. The moment we have a little star, it's currently synced. Okay, you can also see over here the time. You can see that we're off a few seconds, and that's because we restarted the machine, so it didn't even keep the time. Another thing also, you should take the Raspberry Pi, the whole unit, and try to be as close to the window. I purposely didn't put it next to the window so that it won't pick up the satellite so quickly. Let me do that. Okay, so it's going to take a little while for it to start grabbing some data. The first thing we should be seeing is the time. The time should be populated in this field here. And we'll probably see the time here as well. So we're going to have to wait a little bit. Right now it's not blinking green light at all. And this is very, very natural. Now, why is this happening? Well, first of all, I had the dongle really not next to the window. When you're outside in the field, it will look at the sky and it'll populate very quickly. Unfortunately, my windowsill, there's another building right next to it. And so it's a very narrow field that it's looking outside. But I do know, look at that, it's populated the time. I do know that eventually, after a little while, you got to be patient, the time will, that's the first thing it'll do. Okay, you can see now that it's collected some satellite information, and I do have a blinking light, a green blinking light. If I refresh this, it says it's not synced yet, and so you can see the time is not synced as well. This is populating this information, this data, so that's doing good. If you want to clear this window here, just type clear, and then you can type the command. Okay, now it's normal. And the time seems to be synced now. You can see that the internet time and the Raspberry time are very close. Okay, so you have now a proper setup of the GPS dongle. It's blinking green, it's looking at the satellites. We're doing well. But the time seems to be off. If you look at the clock of the Raspberry Pi, which is this one, and then you look at the other clock, which is the clock from the internet, they are not synced. Seems like the clock on the Raspberry Pi is a bit faster. And if you type in cgps, this is the time that the GPS is grabbing. And let's look at the seconds. Seems like the Raspberry Pi time is running faster than the GPS time. Even though we know it's synced. We know it's synced. And if we cancel this, we know it's synced because if we look at the chrony sources, right here we got the pound sign, means local clock. We have the star. Star means what? Current synced. And then NMEA means the dongle. You could type in a command here to sync it again. Sudo sync y, or chrony y, I'm sorry. Sudo chrony c make step. And it'll make the time, it'll reset the time again based on the GPS, but it's not. Let's look at it. It's still not running. Those seconds are, it's just a little bit. Now, a little bit is not too bad, especially when your time is really off. But could it be better? And this is something that you can do, try out. All right, what we can do is we can look at this configuration file, this one right here. Let's copy this and paste it and run it. And then go down here. These numbers, the offset and delay, can be changed. You can change them and manipulate them to your liking. I'm going to delete this, making sure there's only one space here. That should say SHM0 space. So I got rid of the offset and the delay. I'm going to save it, Control X, click on Y, and then enter. So I'm going to get rid of this delay and offset, which is used for network time and for other time mechanism to kind of like adjust for latency. But I don't think there is any latency between the dongle and the machine so much. All right, then I'm going to reboot. Okay, we're back. So let's type xgps, get those satellites up. Let's go with cgps, cgps. And now let's look at the time. I think that's what we really want to know. Wow, that's pretty synced. The GPS clock and the clock for the Raspberry Pi. And then we are pretty close. A little bit better, actually. they're both almost synced at the same time. Now that the internet clock and the Raspberry Pi. Not bad. Not bad at all. Are there any consequences to this? I don't know. But I noticed when I was doing JS8 that I was about 2 seconds off. And I really didn't know why. The last 3 weeks I've been really refining my settings. Ultimately, this could be a mistake. Who knows if getting rid of the offset and delay. Maybe I'll forget. Maybe when I put it into, using it in the home. Maybe that's necessary for the internet. I don't know. What I do know is that I'm going to practice. I'm going to utilize this on the field and see how it works. Okay. Thank you very much for staying this long. It's been a very long process. Hopefully you learned a couple of things as we went along. Please give me a thumbs up. Please subscribe. And pretty soon I'll be creating another video. And thank you very much. This is Frank, KN6BST.